Hokie dokie. In this problem, they give us 3 statements, and the goal is to identify which are true. Starting with number 1. The linear correlation coefficient R always satisfies -1 to 1, including -1 to 1. This is a true statement. The only real way to explain it is this is the definition, or this is the criteria for a correlation coefficient. The closer it is to 1 on either side tells you how closely related the x and y values are, how strongly related or strongly correlated they are. This one was for the negative sloped correlation, and this is for the positive sloped correlation. And then anything closer to 0 just kind of tells you they're not really related strongly, either in a positive or negative direction at all. So the closer it is to 0. All right, so that statement will always be true as long as they have the -1 and 1, including -1 and 1. If they say 0 to 1, that will not be right. All right, number 2. If variables x and y have a strong correlation, in other words, they are very close to 1, or the absolute value of r is very close to 1, then variable y could cause variable x. The could is very important here, because if they said y causes variable x, that would not be true. The could makes it true. And I think the other one's just pretty much the same statement. And again, the could makes it true. So the could is very strong in making this making both of these a true statement. So in this case, all of these are true, all are correct. Let's do a few more examples. Number 1, again, x could cause variable y if they have a strong correlation. That is true. Number 2, for any event, the probability that the event does not occur is probability of the event -1. This is very close. However, they've switched it up. It should be you take 1 and subtract the probability of the event occurring, and that would give you the probability of the event not occurring. So P no event, I guess. And yeah, so this makes it false because they've flip-flopped it. It should be 1 minus the probability of the event. Number 3, to calculate the probability of 2 independent events occurring, we multiply their probability. So like P of, I don't know, x times P of y. To find the probability of both of these occurring, we do multiply their probabilities. I can't really explain it better besides just saying that is what we do. That is sort of the definition of calculating that the probability of those 2 events occurring. So true, false, true. So it looks like 1 and 3 are correct. Let's do 2 more examples. Number 1, a random experiment is a process with certain outcomes. By certain, they mean like they know exactly what the outcomes are going to be, like particular outcomes, very specific outcomes, whatever. And this is false. A random experiment is one with random outcomes. And so that is false. Number 2, to calculate the probability of 2 independent events occurring, we divide their probabilities. We just said that we have to multiply their probabilities, not divide. So this is false. And then we've seen this one already as well. P minus 1 is false. It should be 1 minus probability of the event. So looks like we have false, false, false. None are correct. Yeah, look at that. All right, let's go and do one more. Random experiment is a process with certain outcomes. Again, false. It should be random outcomes. If x and y have a strong correlation, then it may be a coincidence, and there's no causal link between the variables. So the no causal link thing, ironically, is the more important thing, I believe. The may is helpful. Like, it helps you see that it's likely true because it gives you wiggle room. It's not a very firm statement. It's very loose, whatever. So that is a true statement. So again, the biggest thing is correlation does not equal causation. That's why I mentioned the no causal link is actually the more important. All right. Number 3, for any event, yeah, we've seen this 100 times. It should be 1 minus P, not P minus 1. So that's false. Looks like only 2. is correct. And that's all I have. Hopefully these give you some insight to these statement problems. Hopefully you got some good variety in there. If there are any other statements that are popping up that we didn't cover, feel free to ask them in the comments, whatever. I'm happy to answer whatever you have. Hope this helps.